Hi everyone, welcome to my talk. Today I'm going to talk about our work called Virtual. So this is the first in-situ failure diagnosis systems. So people have dreamed to have like automatic failure diagnosis for many decades. Now we have come up a system that kind of achieve this target. So this is the joint work with my PhD student, Hongyu and Sam. And also this is also the joint work with Xiangyi Zhang from Purdue University and Jian Huang from UIUC. I guess everyone will agree with me. Now software is everywhere, like in everyday's life. So you will contact with devices. They will be installed with different software. And if you go travel, you will also use car, train, or airplane. Both, all of them, also install with different kind of software. And also military service, they also have software inside. So software significantly increase our convenience. So if they work correctly. So however, software may have one problem called failures. So if their failure happens, so the hacker can breach your systems. And also they can also cause other problems because they cannot work correctly, so your service may be down. And based on one existing study, software failures affecting 3.6 billion people and cause 1.7 trillion financial loss in 1 year. So that's huge. So how we can solve this kind of problems? So let's take a look at how existing work, how they are doing that. Existing work, typically the programmer, when they finish their program, they will ship the binary to the normal users. When normal users, they are using their software, and then when something is wrong, so you will often see such window pop up. So do you want to send this report to Microsoft? Okay, if you click yes, and it will send out a lot of information, seriously. So for instance, like memory code dump, control for information. So which means what? So for instance, if you just use IE browser to log into your bank account, and then you have a crash. So if you send out this information, you may send out your password, your account name to Microsoft. So this is very risky. So, and of course, I believe Microsoft will not take your information, but who knows whether there's some people in Microsoft will do such things. So basically, they may leak your privacy information. So after Microsoft or other software vendors, they got this information, they can perform a offline analysis and then identify the cause. Okay. So what we're trying to do is propose a new work called virtual that's significantly different with existing work. So when something is wrong, so we can just perform a diagnosis in the same process. So and then normal users just need to take a rest for a few seconds. So and then we can identify what's the problem, and then we can send the root cause only to the programmers. So root cause only, that's not including your sensitive inputs, that's not including any production environment information. So they only including the source code information that will be helpful for programmers to fix the problems. So that's what Watcher is doing. So what's the basic idea of Watcher is doing this? So the basic idea of Watcher is doing is it's just based on one decoder and replay systems. So they can take a checkpoint periodically, and then they will do the normal execution. They will perform very small decoding, and then when there's failures, they will load back the program to the checkpoint, and then you can do we can do a failure diagnosis, the execution, and when we can report root cause. Root cause means why your program will fail. So it's based on our previous work, iRepair. So iRepair is identical decode and replace systems with very low decoding overhead. The decoding overhead is less than 3%. And then like based on that, we design this called in-situ failure diagnosis. Okay, so if you are interested in this work, you may like look at our paper published in UPSTAR 2020. Okay, so if you're interested in our work, you also can contact with me. So I'm not going to like talk about details, but I'm going to like show like 2 examples. So for instance, the first example is Memcached, a widely used programs. So, and then when we run the Memcached, and we can like perform the diagnosis immediately. So we use some script to do that. And we can see that we start the server first, and then we start the client. And then like when something is wrong, we can perform the diagnosis. It only takes like a few seconds, and then we can tell you the root cause, why your program will fail. Okay, so let's take a look at another example, like a transmission. So the Memcached problem is a sequential problem. And then let's take a look at another called transmission. So it's a concurrency problem. So I mean, the same, we will also use some script to run these programs. And then we can see that when there's something wrong, like assertion failure, and then we can identify the why your program will fail, like very quickly, even like faster than like Memcached. Maybe takes few seconds, 3 or 4 seconds, and then like we can report to user why your program will fail precisely. So we can tell user, for instance, you write like one thread write 0 to this memory unit, and then like T0 did this 0. I mean this from this unit, and then cause a program like a surgeon failure. Okay, so we can tell you like the only information necessary for you to fix your bug. Okay, so we perform these experiments on like more than 20 applications. So these applications including different kinds of problems, like stack overflow divided by 0, null pointer assertion, and then like other problems like dangling pointers. So, and this problem including both sequential problem and concurrency problems. So overall, like the last column lists how much time it takes to identify the problems. So in general, it takes less than 10 seconds for a diagnosis. And then like for effectiveness point of view, so we can like, as long as you can reproduce the execution, we can identify what's the root cause. So it's like 5 orders of magnitude, like larger than like repeat. So repeat is a best paper award in OSDI, like 18. So we can do much better than existing work. And repeat is offline analysis, and we use like in-situ diagnosis. Okay, so overall, we provide a new system, use a record replay. So let's go watcher. And also we can tell you the exact root cause, why your program will crash. And if you are interested in this work, so if you are interested in this technique, you can contact with me, use tomping at umass.edu. And we are like very excited to work on that. And we hope like we can collaborate on this project. Thank you for your attention.